This is kind of the culminating video when it comes to graphing trig functions, but I'm going to put all of the pieces together here for graphs of the form y equals a sine bx plus c plus d, also cosine. And you have to recognize that if we're going to talk about sine and cosine, we can include here cosecant and secant, which are the reciprocals, but we say where b is some positive number, okay? But they have the following characteristics. So up until now, we've said these things. We say for graphs like this, at least for sine and cosine, they have amplitudes and they're equal to the absolute value of a. The period of the graph is equal to the original period of the graph. So say it's sine or cosine, its original period is 2 pi. We'll take that and divide by b. Or say tangent, you would take only pi divided by b because it is the only graph besides cotangent that has a period of pi. Its phase shift, we pointed out in the last video here, it's equal to negative c over b. Okay, so this c value is in control of horizontal translation, but it is dishonest. That's why we put this negative out front here, to kind of keep it honest. We say the vertical shift, or vertical translation, is just d here, okay? And then we say if a is negative, then the graph's going to be reflected about the x-axis. So basically, we're going to graph this curve here, and I've listed out a series of steps or protocol to go through when graphing trig functions in general. So we're going to look at this one here. It says y equals 2 sine 3x plus pi. And the first thing I recommend we do is this: identify a, b, c, and d, and then use a, b, and c to determine both these three things here. We say respectively the amplitude, the period, and then the phase shift. Okay, so we say what are our values here? We're going to list them out over here. We say a is equal to 2. Looks like our b value is 3, and then we say our c value is pi, and then we say our d value is, that's a d, that's not a p, d. 0. So we say here are all of our values. So we're going to list out the amplitude. We know that from our chart up here, we say the amplitude is the absolute value of a, which in this case the absolute value of 2 is 2. So we say now, next we say find the period. We just take 2 pi divided by b, because that's the normal period of sine divided by the b value. The b value is 3. So people freak out when they see this. We just call it 2 pi thirds. That's the length of one cycle, which we're okay with that. We say, okay, well, what's next? We say also the phase shift. Now, phase shift. This is kind of the first time that we're listing this, as a formula, but it's negative c over b. So we're going to list it this way. We're going to say negative c value over b value, where our c value in this case is pi, and our b value is, we said, 3. So this is going to shift negative pi thirds. Why don't we write a little note here? This is left pi thirds, let's write it as just this, left pi thirds units on the x-axis, okay? And then we say, how about vertical shift? Vertical shift. And that's just our d value. And in this case, we say none, or 0, okay? Because it's not going to move at all if you don't have a d value. Last but not least, we say, is a negative? Now, the a value is positive. So this means that it's not going to be reflected, but let's write that little note in here. We say not reflected. Okay, so we've determined like all of these things. So step 2, after finding all of this stuff, says on the x-axis, label the starting point, the ending point, and the point halfway between them for each cycle of the curve in question. So when we look at this, we say the starting point is going to be equal to our phase shift. This is the place where we shifted to. So we're going to go left pi thirds units. I'm going to call this left pi thirds or negative pi thirds. So now I mentioned this. We're going to go out to the end, the ending point, which would be the beginning point. Let's label this. We say beginning point. To get to the ending point, we have to add on one period length. Okay, so it's period length in this case. We said the period is 2 pi thirds. So we're going to say what is, let's work this out. We say negative pi thirds plus 2 pi thirds. This would give us a positive pi thirds. So technically, I think that we need to spread this apart just a little bit more. So I'm going to actually call this not negative pi thirds. I'm going to call this negative pi thirds. I'm going to call this positive pi thirds. So we're going to go out, one period length past this. This is a period length of 2 pi thirds. So from start to end, and we say the halfway point. Now the halfway point's got to be 0 here, so that's why I said I'm okay with deleting this right here. Because what we'll do is we'll take this halfway point, label it, and then cut that into our 4 subsections here. Okay? So once we have this, then we should, we said quarter the interval. Once we have it quartered, we're going to use our d value. Now our d value determines if the graph has any vertical shift. And we noticed here that there is no vertical shift, but I'm going to recommend this. We say, if so, draw a dotted horizontal line. We're going to put a dotted, dashed horizontal line at y equals 0. And it's just this imaginary line that our sine graph's going to go around. Now I want you to imagine, what if you shifted your graph up like 2? Our graph would have to go like with an amplitude of 2, 2 above, 2 below, 2 above, 2 below, 2 above, 2 below, but of an original height of 2. In this case, we have an original height of 0. So we're cool here, but always look for your d value to put this imaginary line in first. We say label the y-axis using amplitude. So wait, hold on a second here. We're leaving from a height of 0. The amplitude, we said, is 2. So if the amplitude is 2, we're going to go 2 above and 2 below the primary height, which is 0. This y equals 0. So now we're going to graph this. It says, all right, sketch our curve. So this gets a little bit tricky. You have to practice this a little bit. But we say it's just a sine curve that's not reflected. So a sine curve at its beginning point starts on the ground. A fourth of the way through its cycle is at its maximum. Half of the way through its cycle is on the ground. 3/4 of the way through its cycle is down at its minimum. And then all the way through its cycle back up to 0. So use this process here to go about graphing your trig functions. Cheers.